So the reason we talk about, the reason we study kinetics, the reason we study rates is we want to see if I double my concentration of A, how does that affect how fast this reaction occurs? Does it have any effect? If it does, that means that my concentration A is one of the things that's before slowing down the entire reaction. So it gives us an idea of what collisions are happening fastest and which collisions are kind of slowing down the rate. Gives us an idea of the mechanism. Okay. So what you want to do is you're always trying to figure out like what's the first step, what's the second step. Overall, we can see that two A's reacted to make a B. That B then turned into C plus A. So overall, our reaction was, oops, and this A cancels out, was just A goes to C. So the mechanism is the steps that are telling you the overall. And we're trying to figure out what this is going to be, what the mechanism is going to be. We figure out mechanisms by studying the rate. And we'll see how. So one thing you're doing is you're trying to figure out, well, does this concentration affect the rate? So you carry out a reaction. I've got CH3CHO goes to CH4, methane, plus carbon monoxide, CO. And I'll have different initial concentrations, and I'll measure the rate. I've got the rate of disappearance. So I get the rate using these different concentrations. So right away I can tell, as I double the concentration, the rate is changing. It's 4 times faster. Clearly the concentration is affecting the rate. So let's see more specifically how. So the way we can express how concentration affects rate is with an equation called the rate equation. The rate equation is a general term that describes each reaction. So every reaction has its own rate equation. Rate equation is always going to be rate equals some constant K. It'll be different for every reaction. So if I have a different chemical reaction, it will have its own K. And no matter what the concentrations are, that K stays the same. Only temperature will change this K. So rate equals K times the concentration of one reactant, this guy, raised to some power. I'll go with M. That power isn't the coefficient, so just make sure that like if I have two A's reacting in the reaction, it doesn't mean the coefficient in the rate law is going to be that. That's a very common mistake. Times the concentration of the other reactant raised to some other power. And I also have some catalyst involved. So let's figure out how that's going to be involved. Okay, so the generic thing is that rate is equal to the K constant for that particular reaction times your concentration raised to their powers. So let's see. Those exponents, the M and P, those are the reaction orders. And reaction orders can either be 0, 1, or 2 in fractions. And your only way you can figure them out is by carrying out a lab. So you have to carry out a lab and see, well, what's the change? What is the change in this? So I think we're going to be taking notes on the second page. Okay, so let's see how we would actually change the concentration and see how that affects the rate. So I think the easiest way to do it is to double concentrations and look mathematically what would happen if you have a first order. So rate equals K times concentration of A to the first power. Or second order, rate equals K times concentration of A to the second power. Or when you have a zero order, rate equals K times concentration of A to the zero power. So I'm going to set up a situation where I'm just going to double the concentration and see how the rate is affected. So I know that rate is equal to K times concentration of A raised to 1 for both of these situations. And I'm going to say the first time I carry out my reaction, I'm going to use a concentration of 1. Second time I carry out my reaction, I'll use a concentration of 2. Okay, so let's see how the rate changes mathematically. 1 to the power of 1 is just going to be 1. And then I've got 1 times K, I just have K. Okay, so 2 to the power of 1, I just have 2. 2 times K, I have 2K. So I can see when it's first order, if you double the concentration, you double the rate. So you can always figure it out, but double the concentration means double the rate. Okay. Now I have a second order. So I know in general, rate is always equal to K times concentration raised to the power of 2 for second order reactions. K times concentration to the power of 2. So now I'm going to say the first time I carry this out, I carry it out with a concentration of 1, and then I double that concentration. So 1 squared is 1. 1 times K, I have a rate of K. Now when I double my concentration, 2 squared is 4. 4 times K, 4K. Okay, so I can see if it is a second order reaction, when I double the concentration, I quadruple the rate. So really I square my change, right? Because my change was a change of 2. 2 squared is 4. If my change was 3, if I went from 1 to 3, I would go from 1K to 9K. So I increase by a factor of 3, square that, the change is squared, it's 9. So if you double a second order, so double the concentration, you're gonna quadruple, you're gonna square that change, quadruple the change, quadruple the rate. Okay. And the last one is if you have a zero order. So the rate is equal to K times concentration of A, or whatever your concentration is, to the power of 0. And then you carry that out again. Rate equals K times concentration to the 0 power. So the first time I'm going to carry this out with a power of, or with a concentration of 1, and the second time, concentration of 2. So 1 to the power of 0 is just 1, right? 1 times K is K. Anything to the power of 0 is 1. So 2 to the 0 power is 1. 1 times K is K. So if you have a zero order reaction and you double the concentration, there's no change to the rate. Okay, so what this means is I can double my concentrations, and if the rate doubles, I have a first order reaction. If the rate quadruples, I have a second order. If the rate doesn't change, then I know I have a zero order. We have a little more time. So looking back, actually let's see. So we can try this out. I'm going to go ahead and say, I have to let Rebecca in. Too many distractions. Okay, so I'm going to go ahead and say that I know that rate equals, you can walk right through. Rate equals K times the concentration raised to some power. And I'm trying to figure out what this power is, so N. Okay? The easiest way is to go ahead and say the rate of one experiment over the rate of a second experiment equals all these values for one experiment over all those values for a second experiment. That makes no sense until we actually do it. So let's pick two experiments, 1 and 2. And what you're going to do is you're going to say, well, rate of the first one is 0.02. 0.02, and that is moles per liter second, over, here, 0.02 equals, now I plug all this in. You know what, stop the video, there's no way I'm going to finish this problem. So,